Hi everyone, my name is Tammy. I'm currently work at Coinbase and specialize in on-chain data analysis. I work with two PhD students on Project Counterpoint. Araya is from Cornell University and Lewis is from Imperial College London. So this is a side project outside of my full-time job, and let's get started. There are many different ways to obtain price information on-chain. The two most common ways are, one is to use the oracle provided by off-chain services like Chainlink, and then the other one is to get the time-weighted average price from AMM DEX. With the first approach, it's simple to use, it's cheap, but users need to trust. For example, Chainlink's price data is always correct. They are always good and will not manipulate the data. With the second approach, the data is verifiable on-chain, and it's expensive to manipulate the price. However, since they only provide price pair like ETH against stablecoin, ETH against USDC, or ETH against a DAI, so the user need to always trust the stablecoin is actually worth $1. The goal of the project is to study the empirical relationship between on-chain data and off-chain prices. The motivation is to develop an alternative to proxy the off-chain crypto prices that is verifiable on-chain. So it can be used together with the other two sources I just mentioned and to build a more robust oracle. This is what the model going to be look like on-chain at a very high level. So at time t, I'm going to capture input features that can be derived from on-chain data and then input into function f. And function f will output the price estimation at time t. Then the ideal property of f will be, first of all, it needs to be simple enough to be able to deploy on-chain. And secondly, it's difficult to manipulate function f's output. And then the last, all input features should be verifiable on-chain. Here are some part of the key on-chain features we have from our initial selection. We have basic features that can be easily derived from on-chain data. For example, like difficulty of the block, number of unique senders, receiver addresses, number of transactions, average gas used. We also have more complex feature based on the literature of fundamental economic model. That's because we want to explore the relationship in, for example, proof of work mining market, block space market, or how is it related to activities against the DeFi liquidity pool. The rationale behind it is we believe off-chain prices information may impact how agents make decisions on-chain. And these decisions impact on-chain markets output, which are observable on-chain. So like as a cycle, it will fit into our model to recover original off-chain price information. With the initial set of input feature in hand, we also use different data modeling technique to explore the degree to which off-chain prices can be recovered on-chain. So for example, this is the visualization of the model technique we use. We use a macro random field with a graphical lasso regularization to try to estimate the conditional dependency of time series of the on-chain data and off-chain prices. So we can uncover the empirical relationship between the two different data and find out which feature have a strong relationship with the Ethereum prices. And with the actual model, we use an ensembling machine learning method. I call it the rolling forest, which means I am at time t. And then I use all the data that are available before time t to train the model use random forest algorithm. And then I will apply the train model to between t to t plus c period to recover the price data. And then the length of the periods for recovery the price data can be varied based on you can have 1 day, 1 week, or 1 month's time. And this is the model performance for model use trained for 1 day recovery, 1 week or 1 month. And then you can see that the y-axis is the prediction of the Ethereum to USD price, and then the x-axis is the actual. I think this is the best visualization to show how model performance in a really quick way. And then you can see that model that train for a shorter period perform much better for model trained for a longer period. And then you can also see it is in generally better to have a better model performance on recovering lower price point rather than a higher price point. That's because you have less data available for higher price point on Ethereum. So the summary, the model is not perfect, but it shows a strong potential. It probably cannot use as a price oracle directly, but it can be used to identify red flag on possible oracle issue. So here we propose a new form of oracle with 3 layers. So the first layers will be we get the price data from Chainlink. We refer this as the training price. And then from the second layer, we use the price information from AMMs to check the oracle price are consistent in relative sense. And then for the third layer, we check the chaining prices against the output of our data model to see whether it's consistent across our output and on absolute level. So this is my presentation.